So, hello student, how are you? I hope all of you are well and doing good. So let's start today's session. Okay, today I'm going to start lathe, right? Today I'm going to start lathe. Today is the basically 18th lecture, and today we are going to start machine tool. In machine tool, I'm going to start lathe, right? So let's discuss about the lathe. Let's discuss about the lathe, right? Yeah. Yes. So my dear student, in the lathe basically try to understand there will be a headstock, right? This is a bed, right? This is what? This is a headstock. This is a bed, and there will be a carriage. This is a carriage, right? On which your this is your way, sorry, and this is your carriage on which you can mount your tool, right? On which you can mount your tool. So this is a carriage, and this is the tool post on which you can mount the tool, right? So here let me write down. So this is what? This is the bed, right? This is what? This is bed. Okay, so this is bed. This is bed, and here there will be two rods, which is known as lead screw, right? And lead rod. Lead screw and lead rod. There will be two rods. One is your lead screw, right? And another is your lead rod. So let me write down the name. This is what? This is the lead screw. This is a lead screw, and next is lead rod. And sometime lead rod, or sometime we can call as feed rod also. So is there any revision course for bark? It will come very soon, right? Maybe. Now, so my dear student, this is the headstock. This is what? This is the headstock. Headstock, right? This is headstock. So in headstock, there will be power driving motors. There will be power driving motors. So these are the motors, right? In headstock, there will be a motors. There will be a power driving motor, right? Which can supply power to the spindle. This is a spindle, right? This is a spindle, and in between the spindle and motor there will be a gearbox also, right? There will be a gear box also. This is what? Gearbox. And there is one more thing which is known as, this is a chuck. That is a work holding device, my dear, right? This is what? This is a chuck, and this is a work holding device. This is work holding device. Let's say it is what? It is chuck that hold the workpiece, right? And let me draw here. There is one more thing which is known as the tail stock. There will be a tail stock, right? There will be a tail stock. So this is what? This is the tail stock, right? This is a tail stock, in which this is a tail stock, right? This is what? This is the tail stock, right? This is what? This is a tail stock. So let me write down. This is tail stock. Tail stock. This is tail stock, right? This is tail stock. This is chuck. this is carriage. This thing is known as carriage. Carriage will do a linear motion, my dear. Let me, yes, tail stalk, and this is what, this is the carriage. This is what, this is carriage. Carriage will do a what? A linear motion. Carriage will do a linear motion on the basis of the rotation of either lead screw, right, or on the rotation of basis of lead rod, right. And this is a headstock, and this is the overall view, right. So let me explain you what is the lathe. Basically, a lathe, right, this is a whole a lathe machine. A lathe is a large machine that rotates the work. Here workpiece is going to be rotate, my dear. Suppose that there will be a workpiece, right, this is a workpiece. This is what, this is the workpiece, right, this is the workpiece. So here this is workpiece, right, this is workpiece. So workpiece is going to be what? Rotate, right. Workpiece is going to be what? Rotate here, right. Workpiece is going to be rotate with RPM n, right, a revolution per minute. So here the workpiece is going to rotate, and cutting is done with a rotating cutting is done with a non-rotating cutting tool. Here tool is not going to be rotate. Please understand one point, that tool is not going to be rotate. Generally the shapes cut are generally what? Round or helical. The tool is generally typically moved along the axis of rotation of the workpiece, right. The tool is typically moved parallel to the axis of rotation during cutting, right. Here you can see this is what? This is the headstock, right. So this headstock, this end of the lathe machine, this end of the lathe, I'm talking about this end of the lathe, that is what? Headstock, right. It contains the driving motor and gears. So here the driving motor is there, gearbox is there, right. So power is supplied from the headstock to the various component of the lathe. So power to rotate the part is delivered from here, right. This typically has what? This typically has some lever, so that you can adjust the speed of the rotating workpiece or other part, like this. It has some lever. See, it has some lever like this, right, like this. It has some lever. See here, it has some lever, okay, by which you can adjust the RPM of the rotating workpiece, or to adjust the power to other component of the lathe. So I hope this point is crystal clear, right. So bed is what? This is a bed, right. So this bed, basically this is a bottom pan. This is a bottom pan on the lathe that catches chips, cutting fluid, right, etc. Right. Now this is bed, my dear, and here you can see, my dear, this is what? This is vase, right. This is what? This is vase. Can anybody tell me the function of vase? Can anybody tell me the function of vase? Anybody of you them can tell me the function of vase? Basically ways are what? Are just like a railway track, right, on which carriage will do a linear motion. So basically these are what? These are hardened rails. These are hardened rails that the carriage rides on. Right? Carriage rides on. This is what? This is a tail stalk. This is what? This is a tail stalk. So what is the function of tail stalk? This can be used to hold the other part, okay. Other part means, like if the workpiece is lengthy, let's say if the workpiece is lengthy, right, if the workpiece is lengthy, then you can hold the workpiece with the help of tail stalk. And if the workpiece is not lengthy, then you can hold the tool, right, then you can hold the tool here. This is my tool which you can hold here. This is the tool, okay. Maybe you want to do a drilling operation. Okay, so you can hold a tool here and you can do a hole, okay, in the given workpiece, right? Right. And carriage is what? Carriage, this part, this pink color portion is known as carriage. This part of the lathe, this part of the lathe, this part of the lathe carries the cutting tool. This is the tool post where you can mount the cutting tool, and the motion of the carriage is based on either the rotation of lead screw and your lead rod, either the rotation of your lead screw and lead rod. So I hope this point is crystal clear. Yes, yes, I hope this point is crystal clear. My dear, carriage is consist of several parts, right? Try to understand. Carriage is consist of several parts, right? Let me write down. Let me write down here. This is what? This is a carriage. This is carriage, right? This is carriage. Now carriage can be consist of several parts, like I can divide this carriage into the 5 components, right? Into the 5 components. See here. Into the 5 components. See here. See here. The carriage. Basically in carriage there will be a saddle. There will be a saddle, right? There will be a saddle. There will be a saddle. Carriage consists of what? Saddle. Carriage consists of cross slide. Cross slide. Carriage consists of cross slide. Carriage consists of compound rest. Compound. Okay. Carriage consists of what? Compound rest. Compound rest. Carriage consists of tool post. Carriage consists of tool post. Carriage consists of apron. Carriage consists of apron. So there are various, these are the major 5 components which consist of carriage, which basically basically these are major 5 components of the carriage, my dear. These are the major 5 components of the carriage, right? Now this is a lead screw. Let's talk about the lead screw. If you talk about the lead screw, let's talk about the lead screw here. Let's talk about the lead screw, right? Lead screw. Let's talk about the lead screw. Here I am talking about this lead screw. My dear, there will be a lead screw. This is a lead screw. Are you getting my point? And on that lead screw, basically there will be a acme threads. There will be a acme threads. Threads are there, right? This lead screw have a acme thread. Basically lead screw is what? A large screw with a small thread. A large screw with a small thread per inch used for cutting threads. Okay, as it has a acme threads, right? So it has a acme threads. It has a acme thread. It has a acme threads, right? It has a acme threads. So this lead screw has a acme thread with included angle of with included angle of 29 degree, right? Now basically there will be a carriage, right? This is a carriage. In that carriage there will be a half nut, right? In that carriage there will be a half nut. This is a nut, and that nut is a part of your carriage. So this is a half nut, my dear. This is what? This is the half nut, right? This is the half nut. Now with the help of half nut, the lead screw or the half nut will catch the lead screw. Okay, the half nut is a part of carriage. Here I am going to write that it is what? It is a carriage. So half nut is a part of lead screw, right? Half nut is a part of carriage. So here, look, this is the thing. Now, when the half nut is in closed position, then it will grip the then it will grip the lead screw, right? When the and in that position, when your lead screw will rotate, then nut will do linear motion, and nut is a part of carriage, then carriage will do a linear motion. Is that point is clear? Is that point is clear? Now I am going to explain about the lead rod. Okay, I am going to explain some point about the lead rod. So here is your lead rod, right? Here is your lead rod, my dear. Lead rod basically a rod with a shaft down. Okay, the side used for driving normal cutting feet, right? My dear, let me explain you a very interesting fact. Suppose that if you want to do a threading operation, if you want to do threading operation, and threading operation, okay, or turning operation, right? Threading operation and turning operation. My dear, when you do a threading operation, the lead screw is connected. Okay, let me explain you. This is your chuck, right? And there will be a workpiece. This is a workpiece on which we want a thread. Right? On which we want some thread. Look here. These are the threads which we want, right? So here the cutting tool, this is my cutting tool, right? This is my cutting tool, and that cutting tool basically mounted on your tool post. That cutting tool is mounted on tool post. That tool post is mounted on carriage, and there will be a lead screw. This is a lead screw, right? This is the lead screw. This is a lead screw. Okay, screw. Now when lead screw will rotate, then carriage will do a linear motion, and then the desired pitch is produced on the workpiece. My dear, if you talk about the lead screw again, okay, lead screw having a acme thread, so it has some pitch. That is L. L basically is the pitch of lead screw. Right? Pitch of lead screw. And here you can see this is again a lead screw. Here, and L is the pitch. Okay, here it has some pitch. That is what L, right? And L is the pitch of lead screw. My dear, right? Now according to the linear motion of the carriage, which is based on your rotation of the lead screw, the desired pitch on the workpiece can be produced. On the given workpiece. But if you are doing, let's say, if you are doing only a turning operation, this is again a work holding device, and this is my workpiece. Here you can see right? This is the workpiece, right? This is a workpiece. This is a workpiece. And if I just want to do a turning operation only, right? If I just want to do a turning operation, okay, turning operation, and this is the tool, this is the tool, this is the tool, this is the tool. See, this is the tool. This is mounted on the tool post. This is your carriage, right? And there will be a feed rod. This is a feed rod or lead rod. Sometimes this is called as lead rod, and sometimes we call as feed rod, right? Feed rod. Because in turning operation, we have to provide only feed. Because in turning operation, we have to provide feed, right? We have to provide feed to the along the axis of rotation of the workpiece, right? So if you want to do a turning operation, then lead rod will comes in picture. If you want to do a threading operation on a given workpiece, then your lead screw comes in picture. Your lead screw will comes in picture, right? So I hope the concept is crystal clear, right? I hope the concept is crystal clear. Now, you have seen this picture here. With the help of gearbox, you can increase the speed of the given workpiece, but RPM can be increased in the lathe in geometric progression only. So our next topic is number of spindle speed, right? Our next topic is number of spindle speed. So let me write down number of spindle speed, right? Number of spindle speed, number of spindle speed, right? Number of spindle speed. So here number of spindle speed, here the number of spindle speed is in B. Here number of spindle speed, let me write down this point here, okay. Yes, number of, right, let me write down here, number of spindle speed, number of spindle speed, number of spindle speed is in geometric progression, is in geometric progression, progression is in what? Is in the geometric progression, right? Is in the geometric progression. Is that clear? Suppose that you want to increase your speed in 6 steps, right? In 6 steps. So let me say that there will be n number of spindle speed which is required, just like in your car. How many gear in your car have? Maybe 5, maybe 6, right? Maybe 5, maybe 6, right? So n is what here? N is what here? Number of spindle speed, number of spindle speed, number of spindle speed, okay, which is required. And is what? Number of spindle speed which is required. Is that clear? And is the number of spindle speed. Let's say you want 6 gear, you want 5 gear, right? Right. And here let me write down that n1 is the minimum, RPM or the minimum speed, right? Minimum speed. And you know the speed will be revolution per minute, right? You know the speed will be in revolution per minute, right? Here I told you now the workpiece is rotating, it has some RPM with the help of gearbox, right? So n1 is the minimum RPM, right? Suppose that if this is the minimum RPM N1, then the next speed will be N1R. R is a geometric progression in your word, but here R is a step ratio. But here R is what? Step ratio, right? Next is N1R square. Next is N1R cube, right? N1R cube, okay. Next is what? Next is your N1, right? The last speed, the maximum speed N1 R to the power small n minus 1. My dear, you have noticed that here and here, this is the maximum, this is a minimum. This is what? This is a minimum RPM. This is the minimum speed. This is a minimum speed, and this is what? Maximum speed. Maximum speed, right? This is what? This is a maximum speed. Am I clear? Now you may be wondering, sir, how can we find the RPM? How can we find the R? R is generally is what? Step ratio. Step ratio. R is what? R is a step ratio. So here R is a step ratio. Then how can you find the step ratio? That will be N max divided by N min to the power 1 divided by small n minus 1. Small is what? Number of spindle speed. Let me explain you with an example. Let me explain you with an example, right? Let me explain you with an example. With an example. Let the number of speed which you required, right? The number of speed which you required. The number of speed which you required. N is the number of speed, as I already told you. Number of spindle speed. Number of spindle speed. Spindle speed, and let's say it will be 6 gear, 5 gear, which you want, okay, right? And you have noticed that in the last gear the speed of your car is maximum, right? Let's say N1 minimum RPM, minimum, okay, speed, let's say it will be 100 revolution per minute. Let's say N max, maximum RPM, maximum speed, okay, maximum, and I will write down N min. Basically it is a minimum, so let's say it will be N min, right? Maximum speed, that will be 1000 revolution per minute. Now R is what? 1000 divided by 100, or let me write down the formula first. So R is what? R is N max divided by N min, 1 divided by small n minus 1. So N max is 1000 divided by 100, 1 divided by 6 minus 1. Are you getting the point? Are you getting my point? So this cancel, it comes 10 to the power 1 by 5, right? Let me calculate. There is my calculator. And meanwhile, please you calculate. Meanwhile, please you calculate this thing, right? Yes, I got the calculator. Yes, so what it will be? What it will be? 10 to the power 1 divided by 5. So it will be 1.58, right? 1.58 and 4. You can take it up to the 2 digit. it will be okay, but if you want, you can take 1.58. Now, according to this, the minimum speed, right? The minimum speed which I am going to take here, N1, right? That is the minimum. And next is what? N1R. Next is what? Next is what? See here. See here. N1R. N1R square. N1R cube. N1R4. N1R5. Right? 1, 2, 3, 4, 5, 6. Right? See here. Now, N1 basically is what? 100 RPM. N1R is what? Basically 100, 1.584, 100, 1.584 square, 100, 1.584 cube, 100, 1.584 to the power 4, 100, 1.584 to the power 5. My dear, this is the minimum one and this will be the maximum basically, right? This will be the maximum RPM, maximum RPM, maximum speed, right? It is what? It is the maximum speed. Is that point is clear? I hope so. Now, the value is 100 revolution per minute and it will be 158.4 revolution per minute and it will be 100 into 1.584 to the power 2, 250.9056 RPM, right? It is better that I will write only okay, 9 RPM. This all the units will be in RPM, right? All the units will be in RPM. 397.43 RPM, right? And 4. It will be 629.536 RPM, right? Now 997.185 nearby basically 1000 RPM. Our maximum speed is what? 1000, right? So in this way we can calculate the thing, right? We can calculate the thing. So I hope is it clear? Now somebody some of you can ask me, sir, how can you find nmax and nmin? My dear, as you know, there will be a maximum speed, there will be a v maximum, maximum cutting speed, right? There will be a maximum cutting speed, that is what? V max. Okay, maximum cutting speed, maximum cutting speed, cutting speed, and generally it will be in meter per minute if I'm not wrong, right? V min, minimum cutting speed, minimum cutting speed, that will be in meter per minute, right? Now here please see, there will be a diameter d min and d max, that is the diameter of your workpiece, right? That is the diameter of your workpiece. Let's say minimum diameter of your workpiece, minimum diameter of the workpiece, let's say it will be in mm, right? Maximum diameter, okay, of the workpiece. Now my dear, Vmax basically is what? Pi. Now you want Vmax. So in that case, D should be what? Maximum pi dn, right? And in journal, if I say, right, in journal, you can say that your cutting speed in general, what you can say, that sir, v equal to pi dn divide by what? 1000. Am I clear or not? You can say in journal, sir, cutting speed, okay, pi dn divide by 1000 meter per minute. Then what will be the rpm, my dear? What will be the rpm? What will be the rpm here, right? What will be the rpm? In that case, rpm will be v 1000 divided by pi d, right? And you need maximum rpm and minimum rpm. If I am not wrong, you need maximum rpm and minimum rpm, right? You need maximum and minimum rpm. So nmax v, for that v should be what? Maximum. Cutting speed will be maximum. D should be what? Minimum. In that case, you will get what? Nmax, right? And min, how can you get n min? V should be your minimum into 1000 divided by pi. D should be what? Diameter of the workpiece should be maximum. Are you getting my point? Are you getting my point? This will be revolution per minute. This will be revolution per minute. Is that clear? Is that clear? Yes or no? Is that clear? So I hope this point is clear. So by this way, we can find out the minimum and maximum RPM, right? The minimum and maximum RPM. Now in threading, I told you that in threading operation, right, P is the pitch of the workpiece, and here N is the RPM of the workpiece, and NL is the RPM of the lead screw, right? Also, small ns, number of start, right? Number of start which we produce on the workpiece, right? And lead screw has a number of start, let's say small nl. You want basically in that operation the distance which is produced in one revolution. In okay, for that the tool must be travel the same distance. For that the required relation will be, that is RPM of the workpiece into small ns into P equal to RPM of the lead screw, that is NL, and NL, that is the number of start, okay, that is the number of start of the lead screw into pitch of the lead screw, that is L. So this is a very important relation, my dear. This is the very important relation. Please always remember, right? Please always remember. So for that, I'm going to give one question as an example. Here I'm going to give one question as an example. So please see here. Look, question, right? Let's say a single start thread, a single start thread of pitch 2 mm right, of pitch 2 mm is to be produced on a lathe, right, is to be produced on a lathe, having a lead screw, having a lead screw, okay, having having a lead screw with a double start thread, with a double start thread, right, with a double start thread, with a double start thread, okay, of pitch 2 mm, of pitch, of pitch 4 mm, let's say, of pitch 4 mm, right, of pitch 4 mm. The ratio of speeds between, the ratio of speed, the ratio of speed, right, the ratio of speeds between, you have to find out basically which you, the ratio of speed between the spindle and the spindle and lead screw, right, lead screw. You have to find out the ratio. I hope the question is crystal clear. So let me write down the solution here. So here the solution is very simple. A single start thread, that is NS, is 1, of pitch 2 mm, that is 2, and N is the RPM of the workpiece, okay, and to produce on a lathe having a lead screw thread with a double start, that is NL equal to 2, pitch, that is the pitch of the lead screw is 4, and NL, right. Now we know that N into NS into P equal to NL into N small nl, okay, into L. Now you have to find out the ratio of speed between the spindle, that is your N, divide by your NL. So small nl, okay, into L, NS into P. So small nl basically is what? Small double start 2 and pitch is 4 and NS is 1 and here workpiece pitch is 2. So here the ratio will become 4 by 1. Is that clear? Is that clear? Here the ratio will be what? 4 by 1. Yes. Okay. I hope the thing is very clear. My dear, on lathe, various operation can be completed. On lathe, various operation can be completed like let me show you. On lathe, right, various operation can be accomplished, can be completed. Yes, see here, you can do on lathe a facing operation also, right, a facing operation also, a facing operation also. You can do a facing operation, okay, on lathe, right. Let me show you. Let's say there will be a, this is a chuck, right, and on this chuck there will be a rotating workpiece, right, there will be a rotating workpiece. This is a rotating workpiece, this is the rotating workpiece, right, this is what? This is the rotating workpiece, right, this is the rotating workpiece. And just a minute, yes, see, now this is a rotating workpiece, my dear. This is the rotating workpiece, as you can see. Now this is a chuck, as you can see. Now this will rotate, right, and tool, here you can see, right. So here the tool will move from the outer edge to the center, right, from the outer edge to the center. I hope the visibility is clear. My dear, please see, if you see this thing in this way, right, let me show you the cross section. So here this is the tool, right, this is the tool, and this tool we are giving a feed to the tool, right, we are giving feed that will be mm per revolution, right, and the workpiece is rotating with RPM n, that will be revolution per minute. And this is what? This is the diameter of the workpiece, which will be in mm. So in facing operation, the distance covered, in facing operation, the distance covered by the tool from the outer periphery to the center, okay, in facing operation, how much tool is going to be moved the tool is going to be moved from the outer periphery to the center, and it will be d by 2. And if somebody going to ask you, the machining time, right, what will be the machining time, then we can find out the machining time, my dear. We can find out the machining time, right? We can find out the machining time, right? Machining time will be distance covered, okay, that is d by 2 divide by tool divide by tool speed, right? Tool speed is what? That will be f into n, and if it will be in mm, then it will be in mm per minute. So here machining time, okay, machining time will becomes to d by f into n, right, in minute, right? It's up to you whether you want to convert, okay, whether you want to convert in minute, when you want to keep it in minute, or you can convert in second. So I hope this point is crystal clear. I hope this point is crystal clear. Now on the lathe we can do one more operation. That is what? That is a taping operation. That is what? That is the taping operation, right? Taping operation, right? Taping operation. We can do taping operation. Suppose that the initial workpiece will look like, initial workpiece will look like this. This is the initial workpiece here. You can see this is the initial workpiece, right? This is the initial workpiece. See, this is the initial work, right? This is the initial workpiece. Okay. See. And now we have to do a taping operation. And suppose after machining, we are going to produce that tapered surface, right? Means we are going to remove that workpiece. We are going to remove that workpiece, that workpiece. We are going to remove that workpiece, right? So we are going to remove that workpiece. Clear? It means you are going to produce a taper surface. Is it clear? You are going to produce a taper surface, and that taper surface basically is going to produce here. There will be a tool, and that tool will move, right? And that tool will move, look, in this manner. And that tool will move in this manner. And see here, this is the tool here. So this is going to be what? Move, right? This is going to be what? Move like this. So you can see that the feed of the tool will be in x direction and will be in y direction. So here the feed is here, the feed is here, the feed is in x direction, the feed in y direction. So overall you are getting feed in xy direction. So in taping, to maintain the feed is a very difficult task, my dear. In taping, to maintain the feed is very difficult task, right? Now in lathe, taping will be of, you can do in various way, right? Taping, this is basically, you can do taping maybe of various you can do taping by various methods. The first method is compound slide, if you are talking about. So first method is the compound slide. Basically this is what? Compound slide. In this method we move the tool manually. Okay, here limited movement of the compound slide. Feeding is by hand. Please remember what I am saying. Feeding is by hand and is non-uniform. This is responsible for low productivity and poor surface finish, right? Also, it can be employed for turning short internal and external taper with a large angle, with a large taper angle. So here you can see we are going to produce a taper portion like this. See here. See. So here, this is what large diameter, and this is what in taping you produce a small diameter, small d, right? Right? And there will be a taping length. This is a taping length, let's say small l. There will be a taping length, let's say it will be a small l, right? It will be a small l. So my dear, here there will be a formula, right? This is, let's say, 2 alpha, right? Let's say it is what? 2 alpha, and basically 2 alpha is what? 2 alpha is a cone angle, right? 2 alpha is what? 2 alpha is a cone angle. Is that clear? 2 alpha is your cone angle. 2 alpha is your cone angle, right? 2 alpha is your cone angle. 2 alpha is your cone angle, right? Cone angle, right? Cone angle or taper angle. Sometimes we can say a taper angle also, right? Taper angle. So let me write down. This is what? This is alpha. So my dear, 10 alpha equal to, this is a bigger diameter, right? And this is a smaller diameter. So you can write down that capital D minus small d by 2L, by 2L, right? By 2L. So by this way, this is a relation. You can find out if you know the bigger diameter, if you know the smaller diameter, then you can find out the half taper angle. Here alpha is what? Here alpha is half taper angle. Here alpha is half taper angle, right? Half taper angle. Half taper angle. Alpha is what? The half taper angle, my dear. So I hope this point is crystal clear. Now you can do offsetting by a other method, that is offsetting the tail stock, right? You can do the taping by other method, that is offsetting the tail stock, right? Offsetting the tail stock. Offsetting the tail stock, right? Here offsetting the tail stock. Offsetting the tail stock. The tail stock. Now, how can you offset the tail stock? Look, there will be a workpiece. This is a workpiece. For this method, the workpiece should be of a sufficient length. There will be a, okay, live center. This is a live center, right? This is a live center. Okay, this is a live center. And at the end there will be a dead center which is attached to the, which is attached to your tail stock, which is attached to your tail stock, my dear, right? Which is attached to your tail stock, right? Which is attached to your tail stock. So this is the thing. Now my dear, let's say this is the axis of rotation, right? This is what? This is the axis of rotation. Now the method is offsetting the tail stock. The method is what? The method is offsetting the tail stock. So here let me write down, this is the workpiece length, right? This is the capital L, that is the length of workpiece. Length of workpiece, right? Length of workpiece. Okay, but we are not going to do a full tapering. We are going to do a taper up to some particular length, right? Up to some particular length. And here we are going to offset the tail stalk. We are going to offset the tail stalk. Please see, we are going to offset the tail stalk, right? Please see, we are going to offset the tail stalk, right? You can see here we are going to offset the tail stalk. Here we are going to offset the tail stalk by a small angle, by a small taper angle, by an small taper angle, by an small taper angle, that is alpha, right? Half taper angle by a small half, a small half taper angle, small half HALF, HALF, small half taper angle, right? Taper angle, right? Now we are doing a tapering up to some particular height, and my dear, this is the offsetting height, right? This is what? This is the offsetting height. Okay, this is the offsetting height, let's say H. So H is the offsetting height, offsetting height, right? Offsetting height. H is what? Small h is what? Offsetting height. Now the question is how much h we can keep, large or small. The h should be as small as possible, because if you do a large offsetting, then there the tool will be rotate like this, right? The tool will be rotate like this. So huge vibration will comes into the system, okay, and it is not possible to maintain the machining. So h should be small, my dear. It should be small. That's why alpha is small, right? Now suppose that after tapering, or after tapering operation, we get the final workpiece. After tapering, we get the final workpiece, let's say, right? We get the final workpiece. We get the final workpiece. This is what? Again, this is what? This is the taper. This is what? This is the tapering length, right? This is what? This is the tapering length, and this is the total length. So my dear, we can write that here alpha is small, right? So you can write that 10 alpha equal to capital D. Here this is a larger diameter, capital D, and this is the smaller diameter, right? Small d. Okay, capital D minus small d by, just a minute, yes, capital D minus small d by 2L, right? Also here alpha is small, so you can write that h by capital L, right? H by capital L. So this formula is applicable only if you are doing the method that is offsetting the tail stalk, right? That is what? Offsetting the tail stalk. Now one more method to produce the taper turning, to produce the tapering surface is what? By using the form tool. By using the form tool, right? By using the form tool, right? Form tool. How can I, how can I produce? Suppose that this is a workpiece, right? Suppose this is a workpiece on which I am going to produce the, tapering surface. So here the tool will be, here the tool like this. This will be the tool, my dear, right? This will be the tool. So whatever be the tool taperness, basically this tool comes in a contact with the workpiece. This tool comes in a contact with the workpiece. The workpiece is rotating about its axis, and it will produce a taper surface, but it has some limitation. Okay, let me explain again. So here a special form tool for generating the taper is used. The feed is given by plunging the tool directly into the work. This method is useful for short external tapers, right, where the stiffness is of no conscious, okay, no consent, such as for chamfering, right? Now there is one more method, okay, like taper turning attachment. There is one more method by using the taper turning attachment, taper turning attachment, taper turning attachment. By using the taper turning attachment, by using the taper turning attachment, you can also produce a taper surface. So how many methods are there? How many methods are there? Okay, how many methods are there to produce the thing? This is the chamfering, first method. This is the offsetting. This is the offsetting, right? And another one is what? Another one is form tool. Okay, this is second. This is third. And the fourth one is taper turning attachment. So I hope the system is crystal clear. So thank you very much. So tomorrow we are going to meet with some new topics, right? Thank you.